A newly discovered impact crater due to a new scientific discovery. The largest impact crater on the planet may have just been found within mainland Australia. But, if the reported feature is truly an impact crater, its existence raises many more questions. This is the story of Australia's Deniliquin Structure. For several years, people who looked at the available aeromagnetic maps of Australia with magnetic data display the variable abundance of magnetic minerals in the Earth's crust might have noted a large and circular region which contained less magnetic minerals than the surrounding rock. And, at the edge of this feature there appeared to be a structure, likely 200 kilometers in diameter, which had a higher concentration of magnetic minerals than adjacent rock. Due to how much of a perfect circle this region represented, some scientists suggested that it might represent a buried impact crater. After all, such magnetic surveys have been used for several decades to discover buried impact structures which might otherwise go unnoticed. For example, the exposed Lonar impact crater in India displays the hallmarks of such a structure. In its center is a decreased amount of magnetic minerals while its rim contained a temporary increase. Due to the resemblance, a new higher quality magnetic survey was performed within New South Wales and Victoria. This study, which was published in 2022, not only confirmed the existence of this ring structure in higher detail, but also found another even larger ring measuring 520 kilometers or 323 miles across. This structure is known as the Deniliquin Structure, which is named after its approximate center near the town of Deniliquin in New South Wales. It encompasses a vast area which stretches all the way down to Melbourne in the south, Robinvale in the west, Hillston in the north, and Albury in the east. This suspected impact feature is not only the largest impact crater in Australia, beating out Bedout Crater, but also the largest impact crater in the world, comprising a little more than 2.5% of Australia's landmass, with a little more than 14% of the country's population living within its rim. So, what evidence other than high-resolution magnetic surveys do we have? For one, the 200-kilometer-wide ring which initially rose suspicions was not the outline of the entire impact structure, but rather represented only the diameter of its innermost ring, within which is a central peak. Why is this evidence important? Simply put, at every single impact crater larger than 4 kilometers in diameter on Earth, complex impact crater material during the impact will be pushed towards the center and then pushed upwards, being a hallmark of what is known as a complex crater. Also, there appears to be a notable ring surrounding the Deniliquin structure's outer ring, which is most notable via the location of a series of lakes north of Mosgiel. Since this suspected structure is buried by more than 10,000 feet thick of rock, it should come as no surprise that it is suspected to be more than 400 million years old. In fact, the Deniliquin structure is dated to somewhere between 417 and 525 million years in age. If this is indeed an impact crater, it goes without saying that much like the 180-kilometer-wide Chicxulub crater that wiped out the non-avian dinosaurs 66.04 million years ago, the vastness of the Deniliquin structure certainly implies that whenever it formed also created a deadly mass extinction event. During the current estimate we have for its age range, 6 minor mass extinctions and 1 when the impact occurred major mass extinction occurred. The major mass extinction is known as the Late Ordovician mass extinction, and is considered to be the second deadliest mass extinction in Earth's history, where 443 million years ago 85% of all of the planet's species went extinct in a brief period. This was associated with both falling sea levels and an ocean which suddenly became largely devoid of oxygen.